Welcome back, everyone. We're going to now take a look at writing equations of parabolas in their standard form from a completely different point of view. So I want to remind you what the forms are for a horizontal, we'll call it horizontal parabola. The equation is y minus k times x minus h. And for a parabola, it has a similar form, but it looks like this. X minus h quantity squared is equal to 4p times y minus k. So we should be familiar with those. There's the notes from last time and the homework. What we're going to do is take some information and use it to write the equations of the parabolas. I believe that it's usually easiest to do these by graphing the given information and going from there. So let's see. Letter A, vertex at the origin 0, 0, and it's got a focus of -3. And so I know that this parabola has to open like that. So I know that the y term is going to be squared, and I know that p is going to be negative. All right, so what do we have? We have y minus 0 squared is equal to 4 times p. The absolute value of p is the distance from the vertex to the focal point or the vertex to the directrix, which in this case is 3. So 4 times 3 is 12, but p is negative, so 4 times -3 is -12 times x minus 0, which would be written as y squared is equal to -12x. All right. A vertex of 0, 0, and a directrix of x equal -2, so that's going to be a vertical line at x equal -2. So we know that we have a parabola that opens right. So since it opens right, the y term is going to be squared, but p is going to be positive. And so we have an equation y minus 0 quantity squared is equal to p. The absolute value of p is the distance from the directrix to the vertex. So in this case, that's 2, and it's positive in this case. P is positive in this case. So 4 times 2 is going to be 8 times x minus 0, or y squared is equal to 8x. All right, let's move on to something maybe a little more challenging. A vertex at 0, 0 opens to the left with a focal width of 12. So opens to the left, focal width is 12. Well, first of all, we know that it opens left, right, so the y term is going to be squared. We know that p is going to be less than 0 because it opens to the left. We also know that 4 times the absolute value of p is equal to 12. So we know that the absolute value of p is equal to 3. But since this parabola opens in a negative direction, we know that p is actually equal to -3. So here's where we're at with this problem. We know that the y term is squared, and the vertexes have y minus 0 quantity squared is equal to 4 times p. P is -3, so 4 times p is going to be -12 times x minus 0, and that would be written as y is -12x. Now we're going to move on to some problems where the vertices are not located at the origin and come up with the equations for those parabolas. So in letter D, the vertex is at -5, +3. So 1, 2, 3, 4, 5, 1, 2, 3. That's the focus. And the vertex is at -5, +6, so that's 3 units above that. So we know this parabola opens down, and it looks something like that. So what do we know? We know the x term is squared. We know that p is negative. And in this case, p is going to be negative 3 because the distance between the vertex and the focus is 3. So p is equal to negative 3. And so our equation is going to be x plus 5 quantity squared is equal to negative 12 times y minus 6. All right, the next problem, we're given the coordinates of the focus, which are 2, negative 3, 2, negative 3, right there. And the directrix, which is at x equal, the equation x is equal to 5. So x is equal to 5 right there. I drew that in the wrong place. Let me move that over one. X is equal to 5. All right, and we know that the vertex is going to be halfway between those two. So here's what our parabola sort of looks like. It opens to the left like that. So what do we know? We know that the y term is going to be squared. We know that p is going to be negative, and p is the distance from the focus to the vertex or vertex to the directrix, and the vertex has coordinates, careful with this one, 3.5 or 3 1/2 comma negative 3. Okay? So the distance from the focus to the vertex is 1 1/2, and p is negative, so p is equal to negative 1 1/2. And our equation is going to be the following. Y plus 3 quantity squared is equal to 4 times negative 1 1/2. Well, 4 times negative 1 1/2 is negative 6. And we've got an x minus 3 1/2 in there. All right, next problem. Vertex at 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. So that's the vertex. Directrix at y equals 7, so that's 2 units above that. Okay, and that means that this parabola has to open down like that. And so what do we have? We have the x term is squared, p is negative, and in this case the distance between the directrix and the vertex is 2, so p is equal to negative 2. And our equation is going to be x minus 3 quantity squared is equal to 4p is going to be negative 8 times y minus 5. Almost done. A vertex at negative 3, positive 3, so 1, 2, 3, 1, 2, 3, opens upward. So we know that this thing opens up like that. And it has a focal width of 20. So p is positive, so we can just say right off the bat 4p is equal to 20, because 4 times the absolute value of p is equal to the focal width. So in this case, p is equal to 5. So our equation is x plus 3 quantity squared is equal to 20 for p times y minus 3. And the last one. We have a vertex at 2, 3, 1, 2, 1, 2, 3. It opens to the right, and there is a focal width of 5. So we already know that the y term is going to be squared. We know that p is positive, and we also know that 4 times the absolute value of p is equal to 5. And since p is positive, p is equal to 5/4. All right, so our equation is going to be y minus 3 quantity squared is equal to 4p 5 times x minus 2. And we're done.